A very good morning to all. Welcome to the third session on Protective Relays and Servicing Lab for 5th semester Electrical and Electronics Engineering. In this contents, we will discuss about what is meant by time multiplier settings, plug multiplier setting, electromechanical relay and its specification, DIP switch setting, jumper setting in statics relay and its specification, time setting and current setting procedure in numerical relays and its specification, CBCT, core based current transformer and its application, next lockout relay, next meaning of 1.3 second and 3 second relays. At last we will see multiple choice questions. Okay, in a power system consisting of generator, transformer, transmission and distribution circuits, when a failure occurs on any part of the system, it must be quickly detected and disconnected from the system. There are two principles reason for it. First, if the fault is not cleared quickly, what it will happen? It may cause unnecessary interruption of the service to the consumers. And the second thing is the rapid disconnection of faulted operator limits the amount of damage to it and prevents the effect of fault from spreading into the system. And how it will happen? The detection of fault and disconnection of faulty section or operators can be achieved by using fuse. We have discussed in previous sessions, or relay. In this session we will discuss in conjunction with the circuit breaker. We know that a fuse perform both detection and interruption function automatically, but its use is limited for the protection of low voltage circuit only. For high voltage circuits, relay and circuit breakers are employed to serve the desired function of automatic protective gears. The relay detects the fault and supplies the information to the circuit breaker, which performs the function of circuit interruption. Next, what is meant by protective relay? A protective relay is a device that detects the fault and initiates the operation of circuit breaker to isolate the defective element from the rest of the system. What it will detect? It detects the abnormal condition in the electrical circuit by constantly measuring the electrical quantities which are different under normal and faulty condition. The electrical quantities which may change under faulty conditions are voltage, current, frequency and phase angle. These changes is one or more quantities, the fault signal, their presence, their location and type of the protective relays have detected the fault. The relay operates to close the trip circuit of the breaker. And hence the result which will open the circuit breaker and disconnect the faulty circuit. We can say the relay, the above figure shows the electromechanical relays. There's some fundamental requirements for the relays, like one is sensitivity, speed, selectivity, reliability, simplicity and economy. Basically there are types of relays. One is electromagnetic relay which we are seeing in a diagram. Next we will discuss static relay. In that, microprocessor based relay, numerical relay. Basically there are two types of relay: electromagnetic attraction type and electromagnetic induction type. Okay, in this diagram you can see the plug setting and time setting multipliers. The current setting of the relay is expressed in percentage ratio of relay pickup current to the rated secondary of the CT. The current setting, what is meant by current setting? It is pickup current by rated secondary current of CT. In diagram you can see the plug settings. The plug or tapping is provided on the relay coil so that the changing the position of the plug changes the number of turns of the relay coil as in shown in the figure. In this figure, you can identify the plug is kept at 5. You can see in the diagram. This means the pickup current of the relay will be 5 times the rated CT secondary current. Likewise, if we put that plug into at 8.75, then the pickup current of the relay will be 8.75 times of the rated CT secondary current. For example, suppose if you want that an overcurrent relay should operate when the system current just crosses 125% of rated current, if the relay is rated of 1 amps, the normal pickup current will be 1 amps. The secondary of the CT should be 1.25 amps, and the current setting of overcurrent relay is generally ranged from 50% to 200% in steps of 25%, and for earth fault 10 to 70% in steps of 10%. Next, time setting multiplier. You can see in a diagram in left side there is a mark time setting dial. You can see the time setting dial, and there is a fixed mark also. The operation of the electrical relay mainly depends upon the two factors. Mainly depend on the two factors. First one is how long distance to be traveled by the moving part of the relay for closing the relay contact. You can observe the disc, aluminum disc. How far, second one, how fast the moving part of the relay cover this distance. So far, by adjusting the relay operating time, both the factors to be adjusted. The adjustment of the traveling distance of the electromagnetical relay is commonly known as time settings. This adjustment is commonly known as time setting multiplier of the relay. The time settings delay is dial is calibrated from, you can see in a diagram, it is calibrated from 0 to 1 in steps of 0.05 seconds. By adjusting only time setting multiplier, we can't set the actual time of the operation of the relay. The time of operation also depend on the speed of operation. The speed of moving part of the relay depends upon the force due to the current in the relay coil. Hence, it is clear that the speed of operation of an electrical relay depends upon the level of fault current also. That means the time of operation of the relay depends on the flux setting multiplier. The relation between time of operation and flux setting multiplier was known as time bar PSM graph. When the time is set at 0.1, the moving parts of the relay have the travel only zero point 0.1 times of the total traveling distance to close the contact of the relay. So if we get the total operating time of the relay for a particular PSM, you can observe in a graph, time bar PSM graph. Okay. Next. Next, you can see the technical specifications. If you buy an electromechanical relay, there are the specification. What are the relay? Which is the type of the relay? Either it is a general specification, high voltage relay, latching relay, reed relay. Next, mounting. How it is mounted? A bracket mount or flange mount, DIN rail, panel, PC board, stock or plug-in style. It will specify, or pole specification means either whether it is single pole, double pole, triple four pole, single throw, double throw. The features will be convertible contacts, current sensitive, expandable desk, push to test button, sealed relay, time relay. If you see the contacts, NO, NC, CO, contact ratings, maximum current, maximum AC switching voltage, DC as well as AC and DC switching power. Coil ratings may be AC coil voltage, DC coil voltage, coil AC nominal, DC power nominal. These are the generalized specification. If you buy a particular relay, For example, if you buy overcurrent relay, that is the relay model will be specified CDG11AF014 SAM. This is a particular company. You can see in detail what it is there, what is the relay type, what is the application, what the secondary CT rating, contacts rate, how much contacts are there, flag, burden, overcurrent or earth fault, over voltage or under voltage settings, nameplate. You can see the current rating will be, the secondary will be 1 amps or 5 amps. IDMT, inverse definite minimum time characteristics, will be 50% to 200% in steps of 25%. That means PSM in previous slides what we discussed. Then 20% to 80% in 7 steps of 10% it is for earth fault relays. Then the starting current will be 1.3 to 103 to 105% of current setting, closing current not more than 130%, instantaneous high setting for earth fault will be 100 to 800, for overcurrent will be 250 to 2000%. Overshoot will be 20 times of its setting current. You can see resetting time 4 seconds for 1.3 seconds relay, 9 seconds for 3 seconds relay. We will discuss in future slides what is meant by 1.3 second relay and what is meant by 3-second relay with the time multiplier at 1.0. TM for setting at 1.0. For 0 to 3 seconds, 10 times the current setting or 1.3 seconds, operating time for 1.3 seconds or 3 seconds. Next is DIP. What is the DIP switch and jumper settings in static relay? The acronym of DIP switch stands for dual inline package. A dual inline package switch is actually a set of small manual electronic switches that are designed to be packed with other circuit. The term DIP switch may refer either to an individual switch or an multi-switch unit or the entire unit as a whole. The role of this DIP switch is to allow user to control the flow of electricity around a PCB, that means printed circuit board, or expansion cards, or the electronics or computer peripherals, or therefore changing the operation mode of a device. The main purpose is to change the operation mode of a device. The configuration of wide range of options on PC hardware and peripherals that includes you can the application will be in the motherboard, video cards, hard drives, modems, expansion modules, etc. They are commonly used in universal multi-device remote control to prevent electrical interference leading to accident control of an unintended device. This a standard surface mountable DIP switch is a sort of an array of a basic two terminal on and off. It is having 1 or 0 electromechanical switches assembled with a thermally stable plastic block housing, thereafter referred to generally as jumpers. DIP switches are usually useful whenever selecting of a particular device function requires multiple switches to be toggled to achieve the right output mode. A standard DIP switch may consist of 1 to 10 or 16 or even more toggle switches or rockers, sliders or rotatory switches mounted on a single small block. You can see in a diagram 1 to 8. They are simple component. The beauty of this DIP switch is that have a several toggles arranged in a parallel means that each can be moved to input output independently, potentially offering large number of different combinations. The specification of the static relay. You can see in a diagram it is a type of MV12 over voltage or under voltage relay which is made by L&T. In a lab you can use this model to study. You can use this model to study over voltage or under voltage operation of a static relay. This relay is a single phase over voltage or under voltage relay with one measuring element. The relay can be used for feed up protection in all low voltage, medium voltage, and high voltage substations. DIP switches are provided on the front panel for pickup and time delay settings. The user has a 7 trip time characteristics. The rated voltage will be from 110 volts to 415 volts AC. Frequency will be 50 Hz plus or minus 2.5 Hz. Auxiliary supply will be 24 volts to 110 volts AC or DC. Relay settings, the pickup voltage, over voltage mode 105% to 180% on VN in steps of 5%, under voltage mode 95% to 20% of VN in steps of 5%. In the TMS, time multiplier settings will be 0.1 to 1.6 in steps of 0.1. The operating characteristics, normal inverse for 3.5 seconds in over voltage mode, normal inverse for 5.7 seconds in under voltage mode. Definite time 110 to 100 seconds. Pickup voltage will be same as the set voltage. Reset voltage will be 90 to 95% of Vs for over voltage, 105 to 110 volts, 110 of set of Vs for under voltage. Accuracy will be plus or minus 5% of Vs. Next, if you see the over voltage relay and under voltage relay in previous slide, in next slide you can see the static relay. The microprocessor based relay you can see in a diagram. You can use this diagram also. It is the made by a company Proc Devices. The parameter in the specification they mentioned microprocessor based relay. Rated current will be secondary 1 amps or 5 amps. IDT curves will be 3 seconds or 1.3 seconds. Definite time or instantaneous. Flux settings ranges from 50% to 200% in steps of 5%. TMS will be zero point 0.1 to 2 in steps of 0.05. Definite time will be up to 20 seconds in steps of 0.10 seconds. Rated frequency will be 50 Hz. Burden on CT is less than 0.2 VA. Auxiliary voltage 85 to 275 volts AC or DC. Relay output 2 CO 30 watt 8 amp DC and for 250 volts AC. Operating temperature minus 5 degrees to 55 degrees. Mounting type is flush or drain in rail. Dimension and panel cutout. In this, the numerical relays, they are evolved from the static and electromagnetic relays. They are basically a device used for measuring the electrical parameters in an electrical network and convert them into numerical data which undergoes mathematical and logical analysis to decide and tripping an electrical network. The main purpose of numerical relay is to protect an electrical network from unexpected faults. These relays perform preferred because of their versatile characteristics. A single numerical relay can monitor multiple parameters like current, voltage, frequency, onset time, offset time, etc. And the same relay can be used for analysis and monitoring the multiple faults such as overcurrent, overfluxing, different current modes, and more. So this numerical relay has gained more importance nowadays. It is the it is used in everywhere in a power substation and distribution controls. Next, we can see in a diagram relay plug setting ranges: low range setting IDMT, high range setting, low phase setting, earth phase setting, definite time settings also. And TMS range for low settings will be zero point 0.1 to 1.6 in steps of 0.01. For high settings in steps of 0.1 and definite time settings in set of 0.1. Next, what is the procedure to change the PSM and TSM in a numerical relay? What is the time setting procedure? First, if you see in a diagram, there will be a push button type. You can see in a diagram there is a set reset push button and the push button for arrow mark to change the parameters. In that initially This diagram, which is showing as a numerical over voltage and earth fault relay, which is made by proc devices. You can see, you can use this model also. You can use the different types of models which by the different companies. We in our lab we are using this type of relay, numerical relay. First, connect the suitable auxiliary supply referring the wiring diagram to pin 13 and pin 14 of terminal blocks. First display shows what is the company name and what is the model name, and display appears as in the main screen indicating R, Y, B phase and E primary current magnitude. Initially it will be 0. If the primary fault magnitude is above 1000 amps, the display as well as event recorded as 1.0 kA. Second step, hold the set R for FRST, reset for a key for 3 seconds. The display changes to relay setting mode. If the password enabled in the previous settings, it will be appear like this. Now the enter the factory reset password is 1000, and then it will be enabled. And then the display changes to password option enable or disable. In this mode, the password can be disabled by pressing the key are enabled. Then next will be the CT rated current. The display changes to relay type of relay by 5 amps, 1 amps or 5 amps. There is a configuration mode. In this configuration mode, now select 1 amps or 5 amps by using the key and press the set button to go to the primary CT ratio configure mode. Then it will display primary CT ratio mode 5 bar 5, 5 to 3000. In this mode, enter the CT ratio by using the key. After selecting the CT ratio, press set or FRST key. For example, CT used is 100 bar 1. Next, CT ratio will be 100 bar 1. Then it will display phase set PS 0.50. Next, it is used, the CT used is 100 bar 5. Then the display change overs to phase low setting PS configuration mode. In this mode, enter the plug settings. Here you are actually, you have to enter the plug settings by using the key arrow mark in steps of 0.01. After selecting the PS plug setting, press the set key. Note, for 5 amps relay, phase current bandwidth ranges from 0.1 to 2.5 steps in size of 0.01. These are the things which will be given in a manual book. You have to read carefully and operate. After that, you have to select the characteristics, IDMT characteristics. After that, pressing the set display change to phase to TMS time multiplier setting configuration mode. In this mode, select the required phase time TMS by using the key in steps of 0.01. After selecting the TSM, press set. Now, this is the procedure to set PSM, TSM in numerical relay. Okay. If you buy different types of companies of numerical relay, you have to go through the manual, and by using the push buttons, by selecting the proper way settings procedure, you can change the plug settings and time setting multiplier settings. Okay. You can see the technical specifications of a numerical relay. There will be a rated current of 1 amps or 5 amps. Frequency will be 50 hertz. Time multiplier will be 0.1 to 2 in steps of 0.05 seconds. There will be a accuracy, contact ratings, relay, auxiliary relay, output contacts, indication, burden on CT. Next, temperature, operation. This will shows the specification of numerical relay. Next is CBCT, that is core balance current transformer. You can see in a diagram the ring type is the most usually used type of core balance current transformer. Cable is passing through the center of the CT. In that way forms the primary winding. CBCTs are employed for providing earth leakage protection in a power system. They are different from normal protective and metering CTs due to their performance requirement. These CBCTs are different from normal CTs. Such earth leakage current should not be allowed to exist for a long period of time since they are eventually causes insulation failure on healthy phases and subsequently developed into face-to-face fault or double phase to earth fault. Initially, if we leave the leakage current, initially it will be small. Even though it is small, if you live in a system, it leads to a severe damage. So that the leakage current should be identified and given a suitable protection. Secondary of CBCT is connected to the earth fault relay. During the normal operating condition, actually the vector sum of three-phase current will be zero. Therefore, no residual current will be in a primary will be present. Hence, the residual current means zero sequence current. There will be not be any flux produced in CBCT core and hence no current in the secondary of the CBCT. This is the advantage of CBCT for earth fault protection, that only one core CT core is used instead of three CT cores in conventional system. Usually before the CBCT emerged, for three phases separate three CTs were used. Now in advancement you can see you can use a single CT. The magnetizing current required for the production of particular secondary current is reduced by one third, which is a great advantage. Also, the number of secondary turns does not need to be related to the cable rated current because no secondary current flows under normal operating condition. This allows the secondary current to choose optimize the effective primary pickup current. The core balance CT is normally mounted over a cable at a point close to the cable gland on the switchgear. In case it is already laid in a switchgear, physically split core, which is known as split over type CTs, can be used. The application will be used in electrical measurements, electrical protection, time relays, process control, and automation components to protect the cable circuits and over a transmission lines with cable termination. Next, lockout relay. Lockout relay is the electromagnetic mechanical relay which latches its output contacts. As the name suggests, this relay once operates lockouts the circuit. Lockout means the circuit cannot be normalized unless the relay is reset. The relays have two types of coils, operating and resetting coil. The operating coil, when energizes, operates the relay. Resetting coil is energized to reset. This relay is not self-resettable. It requires manual resetting of normalize the protection and trip circuit. Any protection relay can be made to be latched its output contacts to provide lockout function. But it is possible to use a single lockout relay that is called as master trip relay and its ANSI code is 86. Next, meaning of 1.3 second and 3 seconds relay. This usually the mechanical relays what we discussed in previous earlier slides, electromechanical relays were developed in 1800s. They were the first form of electrical production while still being reliable and widely used. These were suppressed by static relays in late 1980s. Static relay have no moving parts, hence the name is called static relay and operated on the basis of analog circuitry. Since the recently static relays have been suppressed by first digital relay and now you can see the numerical microprocessor based relays which we discussed in previous slide. This type of relays operating time is inversely changed with current. So the high current will operate over current relay faster than the low ones. There are different types of relay settings. You can see in a diagram. You can see in a diagram. This is a discrimination by both time and current. The relay operation time is inversely proportional to the fault current. The operating time of the relay can be moved up or made slow by adjusting the time delay settings. The lower time delay settings will be fast operating time is generally from 0.5 to slowest to 10. It gives the inverse time characteristics to lower fault values, current and definite time characteristics for higher values. These inverse characteristics obtained by using plug setting multiplier and time setting multipliers. IEC standard of 60255 curves and IEC, this standard gives the four different types of characteristics. One is standard inverse, one is very inverse, one is extremely inverse, one is long time inverse. By using the formula T is equal to K divided by I divided by IS power of alpha minus 1 into TMS, where T is the tripping time in seconds, I is the fault actually secondary on CT, which is seeing, IS is the relay pickup current setting, TM is the time multiplier setting. By varying these parameters, you can see in a diagram, relay characteristics are sometimes classified according to their tripping time at 10 times the current setting. That is 3 seconds bar 10, a standard inverse which will trip 3 seconds at 10 times the current setting. You can pick up the pickup settings can be by 10 times can be varied, but the operating time will be 3 seconds. The tripping time for the various relay will be for standard inverse 3 seconds or 1.3 seconds. That means how the 3 seconds will be converted into 1.3 seconds means, if you have a 3-second relay trip curve, you can just multiply the time with 1.3 and divide the answer with 3, then that's the time of the relay will be 1.3 seconds. Next is very inverse, next is extremely inverse, long time standard earth fault, that is very fast, 13.3 seconds per 10 seconds settings. Okay okay next we will see multiple choice questions. The function of the relay is to, what are the options? Detect fault, interrupt circuit, detect and interrupt both of these. The answer will be detect fault. The relay, the function of the relay is to detect the fault. If you see the fuse, the function of fuse is to detect and interrupt also. Second question, relay can be actuated by frequency of the waveform, current level, phase angle, all of this. Yes, the answer will be all of these. The relay can be actuated by the frequency of the waveform, the current level and phase angle also. That means the abnormal condition in a system either may be phase angle difference, current or voltage. For these parameter, if they varies, the relay will sense and the abnormal condition, these electrical quantities are measured and the tripping signal will be given to the circuit breaker. Next question. Plug settings of an electromagnetic relay can be altered by. Options are using a CCVT, varying the number of ampere turns, changing the width of magnetic path, air path, none of this. The answer will be by varying the number of ampere turns. Fourth question. Microprocessor relay is a type of which relay? Electromechanical relay, static analog relay, static digital relay, all of this. The options will be static digital relay. It is a static digital relay. Next, relay gets its operation energy from transformer, options, alternator, overhead lines, CT and PT. The relay will get the information from CTs and PT, that is by current transformer and potential transformer. In the time setting multiplier, what we discussed in the earlier slide, if the total traveling distance is divided and calibrated from, the options will be 0 to 1 in steps of 0.05, 0 to 10 in steps of 0.05, 0 to 100 in steps of 0.05, 0 to 1 in steps of 0.5. In the diagram in the slide, we have discussed that TMS, time setting multiplier. According to that, the time setting will be 0.1, 0 to 1 in steps of 0.05. That is, the option will be A. Okay, next, what is the full form of PSM? Plug setting multiplier. TSM stands for time setting multiplier. Next question. A core balance current transformer or CBCT used for electrical measurement, electrical protection, time relays, all of the above. Answer will be All of the above. It can be used for electrical measurement, electrical protection, time relays, etc. Next question. Plug settings or current settings of overcurrent relays generally ranged from, the options will be 50 to 200%, 10 to 70%, 150 to 200%, 50 to 1500%. Actually, for overcurrent, if you say for overcurrent, the option will be A, 50% to 200% in steps of 25%. Option B will be used for earth fault relays, 10 to 70% in terms of 10% for earth fault relays. The answer will be option A. Next, you can see the answers which we discussed in the above MCQs. These are the references.